E1 equals to F2 over E2. So whatever you are asked to find, you just slot in the value. Friend, welcome to class today. Today we'll be talking about Hooke's law, and I will show you simple tricks to answer questions on elasticity and Hooke's law. I'll be talking about Young modulus, I'll talk about tensile stress, tensile strain, I will talk about energy stored in an elastic material. So I want you to pay attention. The first thing you need to know is the definition of the Hooke's law. Hooke's law states the extension on an elastic material or on a spring is directly proportional to the force applied to it or the load applied to it. So meaning that if I have a rubber band, okay, if I apply little force to draw this rubber band, which is an elastic material, then there will be a little extension. But if I extend the rubber band longer, okay, apply more force, okay, if I apply more force, the more force I apply, the more the extension, provided the elastic limit is not exceeded. If the elastic limit is exceeded, this rubber band will break. Alright? The rubber band will break. So if I just apply little force, the extension, so this increases the extension. This is the original length of the elastic material. But if I add more force, the extension increases. So the law states that the extension on an elastic material is directly proportional to the force applied on the load, provided that the elastic limit is not exceeded. Mathematically, you can express that as the force applied is directly proportional to extension. Now, because of this proportionality sign, we need to change it to equational sign. So I will introduce a constant. So I have F equals KE, where my F is the force in Newton. It's the force of the load. The E is the extension in meters, and my K, I can call it the spring constant or the force constant. The force constant or the spring constant. Alright, now with that being said, let us try to see some examples of questions you could be asked under this introductory part of elasticity. Here is the first question. A load of 5 newtons gives an extension of 0.5 centimeters in a wire which obeys Hooke's law. What is the extension caused by a load of 20 newtons? So this, we have the first load gives this extension. So we can say our F1 is 5 newton and then our E1 is 0.56 centimeters. Now, they can give you extensions in millimeters, they can give you in centimeters, so you need to know how to convert it to meters before you can use it. So anytime you have centimeters, converting centimeter to meter, just multiply by times 10 raised to power minus 2 meters. That is how to convert from centimeter to meter. While from millimeter, it is times 10 raised to power minus 3 meters. So if you are giving 3 millimeters, it will equivalent to 3 times 10 raised to power minus 3 meters. In centimeters, it will be times 10 raised to power minus 2. So here, it's going to be 0.56 times 10 raised to power minus 2 in meters. Alright, now a load of gives this extension. Then assuming Hooke's law is applied, what is the extension? So I need to first find the force constant. And my F is KE. So if I make K the subject of formula, my K is going to be F divided by E. And that is 5 newtons divided by extension, which is 0.56 times 10 raised to power minus 2. So without wasting time, how do I solve this? This 10 raised to power minus 2 comes up and it becomes 10 raised to power 2. That is 500. So I have 500 divided by 0.5 to be my K. My K is 500 divided by 0.56. Now the question says, what is the extension caused by a load of 20 newtons? So if my F2 is 20 newtons, extension 2 is unknown and the K is constant. So my K is 500 over 0.56. So my F2 equals to KE2. Alright, to find my E2, I divide both sides by K. So my E2 is going to be F2 over K. My E2 is going to be, F2 is 20 divided by my K, which is what? 500 over 0.56. That's going to be 20 times 0.56 all over 500. So our answer is going to be 0.0224 in meters. But the options we're given is in centimeters. So if I convert this to centimeter, I multiply by 100. If I multiply by 100, the extension is going to be 2.24 centimeters. So that is the answer, 2.24 centimeters. That is my E2. Here is a much simpler method you can use to answer this question. Faster method you can use to answer the question. All you just need to do, you remember that F equals KE. So your K is a constant and that's F over E. So the formula you can use that will make this faster to solve is F1 over E1 equals to F2 over E2. So whatever you are asked to find, you just slot in the value and you make it the subject of formula. So here, the extension in a spring weighs 5 grams. So our F1 here is 5 grams. Weight was hung from it was this. This is our E1, 0.56 centimeters. If Hooke's law is obeyed, what is the extension cost? So we are looking for E2 unknown by a load of 20 grams. Our F2 is 20 grams. So you just slot in the values into here. We are looking for E2. So let's make E2 subject of formula. F1 E2 equals to F2 E1. Divide both sides by F1 to be able to get E2. Alright? This cancels this. So our E2 is going to be F2 E1 over F1. And our E2 is going to be, what is our F2? 20 multiplied by what is our E1? 0.56 divided by what is our F1? 5. So if I divide this, 5 here, 4 multiplied by this, my answer will be 2.24 centimeters. Can you see this is a faster method compared to the first? I'm getting the same answer, but it's faster. So this is a much cheaper method to answer these questions on Hooke's law. I hope that is clear. Here is the second question. The extension in a spring when 5 grams weight was hung from it was 0.5 centimeter. If Hooke's law is obeyed, what is the extension caused by a load of 20 grams? So here, the first force or load is what? So let me use load since it was weight now. So L1, load 1 is 5 grams. They said the extension it produced was 0.56 centimeter. So the extension 0.56 centimeters. If Hooke's law is obeyed, what is the extension caused by a load of 20 grams? So L2 is 20 grams. The extension is unknown. So in this situation, since this is centimeter, what we are looking for is in centimeters, so you don't need to convert this to centimeters. Of course, this is in grams, this is in grams. So you also do not need to convert this to maybe to kilograms first, then to Newton, which is the force. But assuming it's just a value direct, you are not comparing two values, you need to convert this to Newton. But now that you are comparing two values, you don't need to convert. So your L1 is equals to, that is your F1, force is equals to KE. Alright, so our K is going to be F1 over E1, and that's going to be 5 over 0.56. That is our K. So we are going to use that because it's the same elastic material. We use this constant for our second question. So F2 equals to KE2. And we are now looking for E2. We divide both sides by K. Alright? So my E2 is going to be F2 divided by K. And what is the F2? 20 over 1 divided by, what is my K? 5 over 0.56. My E2 is going to be 20 times 0.56 all divided by 5. And my answer is going to be 2.24 centimeters. That is 5 here, 4. If I multiply this by, I'm going to get 2.24 centimeters. And option E is the correct. And I believe you understood what we've done so far. So I'm going to give you this assignment. I want you to try out this question. Go to the comment section and post your answer there. And do not forget to share this video with your friends and like the video. If you have not subscribed to our channel, do well to subscribe to our channel and hit the notification bell so that you could be informed anytime we drop a new content. Thank you. Now here is the assignment. A 10-gram mass placed on the pan of a spring balance causes an extension of 5 centimeters. If a 15-gram mass is placed on the pan of the same spring balance, the extension is dash. So calculate the extension and go to the comment section and drop your answers there. Thank you very much. See you in the next video.